All right, let's see here. It's 3:15, and I'm going to supersede Brooke, and we're going to get this thing started. You're going to be in strategies and practices for building soil health on the modern organic farm with Shawn Lucas. And very early in my career, I found the value in Kentucky State University and the tremendous resources and specialists that they have, and I've really taken advantage of that. And one of them is Shawn Lucas, and Shawn is an assistant professor of organic agriculture at Kentucky State University. He is a certified crop advisor and an expert on organic and/or sustainable crop production systems. Shawn is formally trained as a soil scientist and has focused much of his career on understanding best management practices for building soil carbon and soil health and agroecosystems. I'm going to need these from you. I'm trying to get the moderator of this conference, and I need these back from you. So please, just do me a favor and fill these out. They really do help us. Shawn.
Thank you, David. I'm excited to be here. I'm excited that you're all here. Everybody hear me all right? I'm normally a wanderer or a migratory species when I'm up at a presentation, but I'll stick to the podium as best I can today. I am trained, as David mentioned, as a soil scientist, and I've spent the last 23, 24 odd years thinking about soil carbon and soil health. And so to me, it's pretty darn cool to see this area of interest is really catching the wave right now. People are super excited to talk about it, super excited to think about it. You know, the conversations around keeping carbon in the soil and not in our atmosphere are ongoing and being funded by USDA now, opportunities to get funding to do this kind of work. It's exciting. And so I'm glad to be here. Oak is, I tell everybody, it's my favorite conference. I get to see familiar faces and new faces, and everybody's here to learn from one another. And so thank you for coming in. I'm going to talk a little bit about soil health this afternoon. I've been notorious for hemp, and I know about organic, but soil health has kind of been my bread and butter over the years. This is a new idea, but it's also an old idea. And farmers and people in agriculture have been thinking about soil health for a long time, maybe not using the term soil health, but there's been a sense of what it is. And so one of the first people, we are at Kentucky State University. We're an 1890 land-grant university, and we are a historically black college and university. And so one of the people that often doesn't get the recognition that he should get in conversations about where this idea of soil health came from is George Washington Carver. He was at Tuskegee. I'm sorry, I thought I untoggled these bullet points. But when he was at Tuskegee, he studied at Iowa State for a while, and he knew Henry Wallace when he was there. We'll talk a little bit about Henry Wallace here in a minute. But George Washington Carver was teaching sustainable farming techniques in the late 1800s, early 1900s, and he had a mobile wagon that he would take around and show producers his ideas about sustainable farming. We didn't call it organic farming back then, but a lot of the things he talked about were what we think of as, methods that we use in organic farming now. He was thinking about crop rotations. He was promoting the idea of putting nitrogen-fixing crops into your rotations. He came up with a very prominent rotation using peanuts, soybeans, cowpeas, and he also has sweet potatoes in it. Some of his rotation ideas are still used in the South where they grow cotton. Obviously, I don't know much about those because Kentucky's not a cotton-producing state, but his cotton rotation, which included, I think, peanuts and sweet potato, and maybe in some off years corn, they're still using in cotton-producing areas. There's his mobile wagon. He was extension agent, right? Bring information to the people and talk to them about sustainable farming practices. As I mentioned, he was friends with Henry A. Wallace. And if you don't know Henry Wallace, he used to be Secretary of Ag back in the 1930s under FDR. And Wallace was the first person that really used this word soil health. And he was writing a thesis, a term paper, a thesis, when he was an undergraduate at Iowa State. He really wasn't thinking about what we think of as soil health today. He kind of had more of a soil fertility-based concept where we're talking about nitrogen, phosphorus, potassium, and of course that stuff is important, but he wasn't really thinking about the idea of managing the living soil and the organic matter in the soil. So this idea of soil health was out there, but it kind of, was nebulous and was still kind of forming. And really, we're still kind of forming what soil health really is. In the 1930s to the 1980s, people started thinking about it more, and they started recognizing that soil health is kind of like human health. It involves life, right? I mean, so Soil Health and National Wealth, this publication that came out in 1936, they're talking about plants, animals, bacteria, molds, lichens, moss, algae, worms, insects, and they're talking about the role that they all play in a healthy soil. You get further into the 30s, and people start thinking about, well, if you're keeping your soil healthy, is that connected to human health? And yes, so this fellow Wrench was a scientist way back in 1939. I mean, if you've ever been to Oak before and you've heard Max Stone talk about organic produce, and he is talking about how people come to him and buy his organic produce as a preventative measure, right? If you keep yourself healthy up front, you're not going to end up in the hospital maybe, right? Or you at least do what you can, right? And people were making these kind of connections back in the 30s. And you move forward into the 70s, and people were starting to put together that healthier soils may give you advantages with disease suppression in your crops. And again, moving forward, people were starting to think about soil health. Well, this is part of environmental health, and if we're in a healthy environment, then maybe that creates healthier people, right? Societal health. And so all this stuff is kind of fitting together. And we're going to take another step back, right? This is a famous quote from Roosevelt, right? Henry Wallace was his Secretary of Ag. But Roosevelt, after the Dust Bowl happened, he recognized that this was a problem. And one of his famous quotes is, "A nation that destroys its soils destroys itself." The NRCS was founded under Roosevelt. It was the Soil Conservation Service then. But you can see some of the destructive things that happened back in the Dust Bowl, that dust cloud, and I've heard stories, people tell stories about the dust clouds in Oklahoma ended up making the white buildings in Washington, D.C. tan, right? And so that's a pretty impressive narrative when you think about the amount of soil that must be being carried and deposited across the United States from west to east to get that kind of effect. If we're not taking care of our soils, we'll get crusts. And if you're a plant, you can't get through that crust, right? You don't want to deal with that. In this lower picture here, let's see if I can get there we go. Now let's see if I can throw it up there. Hey, it works. Right, so here we got erosion, right? We're not keeping that soil covered. This is probably what we'd call a conventional operation. I don't like that word conventional because even within conventional, there's a wide range of practices that, range from not sustainable to kind of sustainable to very sustainable. It depends on management. So I don't like that word conventional, but for lack of a better term, we'll put it out there. And that field's not covered, and we're getting erosion. And then in the 90s, when I was really sort of figuring out who I was and eventually ended up in a soil science program at University of Maryland to work on a master's degree, this idea was coming around about soil quality. And what was soil quality? And this was a real hot topic when I was a graduate student. People were defining soil quality. And they came up with this idea that soil quality is this ability of a soil to carry out certain functions, right? Well, if you want to build a house, maybe there are certain soils that are, high quality soils for building a house. If you want to make pottery, there are certain soils that are more suited than others to make pottery, right? If you want to grow crops, then you want to work in a soil that's, prime agricultural land, good for crop production, right? But this idea of soil quality didn't really get to soil health when we start thinking back on, some of the earlier things that people had thought about and about the life in the soil. And so the notion of soil health then kind of evolved out of that concept of soil quality, which a lot of scientists and extension, USDA folks kind of defined as, the ability to carry out certain functions. But then soil health starts refocusing things on that living soil, the importance of the biology. And soil health is something that is tricky to assess, but we can assess it. We can test our soil health and get, take measurements in our soil that help us monitor our soil health. And if you're monitoring your soil health, then that can help you make decisions on how to manage your resource, your soil resource, on the farm. There's a mixed cover crop here. We just heard an awful lot of good information about cover crops from Jesse and Susanna. And it's always hard to come into a conference like Oak and figure out exactly how to tailor your presentation, because folks like Jesse and Susanna have been doing this for a long time, and they know what cover crops are all about, and they know all about putting carbon in the soil. And then you got folks that might be beginning farmers. And so you try to hit the sweet spot, and hopefully I've done that here. This is a mixed cover crop with crimson clover, rye, and winter peas. And so obviously that's a winter cover crop. You're going to plant that in the fall. And you're going to get good biomass above ground. You're going to get the rye generating a lot of carbon when you terminate that cover crop. And the pea and the clover will generate nitrogen because they are leguminous plants. And so moving forward, this idea of soil health has evolved. And there's a couple of these are sort of official definitions of soil health: the continued capacity of a soil to function as a vital living ecosystem. So we're focusing on the life, right? The life that sustains the plants, the animals, the humans, the microorganisms in the soil. The plants depend on those to recycle nutrients. We depend on those to decompose our waste and feed the plants, right? And so this living ecosystem, and an ecosystem is this environment where things are interacting, right? And so this definition of soil health is really taking into account the life and the interactions. And so that was the USDA definition. The UN Food and Agricultural Organization defines it as the ability of a soil to sustain productivity, diversity, and environmental services of terrestrial ecosystems. It's a little more like that traditional soil quality definition, but again, they're talking about carrying out environmental functions that we kind of take for granted, right? Unless you really sit down and think about it. Ecosystem services, you'll hear that word or those words thrown around when we're talking about soil quality or soil health, and it's just the benefits that people get from a healthy soil or a healthy ecosystem. And again, we take advantage or take for granted, we take advantage and take for granted a lot of these ecosystem services. If we have a healthy soil and it's functioning properly, these are some of the things that we might take for granted that healthy soil is going to promote. So air movement and structure, if we look at, then we got to find it. No. There we go. So we got air movement. I've had too much coffee and my hand's jiggling too much, right? That's a pretty good structured soil. It looks like a healthy soil. It's got worms moving through it and roots moving through it, air moving through it to facilitate the aerobic needs of that root system. It's a habitat. We can see the worm there, but there's lots of other things living in that soil: fungi, bacteria, algae, mites, collembola, different arthropods, nematodes, right? All these things are living there in that soil and interacting in that ecosystem. Decomposition. I mean, if we didn't have decomposition, we'd have a lot of cow patties just sitting around, wouldn't we? Those cow patties get turned into plant nutrients in a good agricultural system. We depend on that nutrient cycling. If we come down here, there we go. We don't necessarily think about this one, but we get our water out of the Kentucky River. But before that water is in the Kentucky River, a lot of it's moving through a field somewhere, right? And down into the groundwater. And that soil is the first line of filtration before that water gets into the river, and someone's taking it out of the river in a pipe and running it through a treatment plant, and eventually we get it in our taps, right? But that soil is really the first line of filtration, and the organic matter in the soil is key in that filtration process. And so now we get back to what we're doing on the farm. If we're building soil organic matter and that water is moving through our crop fields, you're creating a better filtered water before it gets to the Kentucky River, right? And then comes into our taps, and we're drinking that. So we're getting back to this whole idea of the life in the soil interacts with us, right? We're dependent on it. And if all these things are working well, then we might have a good medium for crop growth, right? And that's what we're concerned about in large part here. As I mentioned, this key critical thing that we can manage to promote soil health, the thing that we can build or ruin, right, is soil organic matter. It's related to lots of things that we care about on the farm, nutrient cycling. You have more organic matter, you have more microorganisms. The microorganisms are responsible for that nutrient cycling of organic matter. Soil structure, which is air movement, water holding capacity. More organic matter in there, those soil, sand, silt, and clay particles stick together better and create structure that allows air and water to move through and roots to penetrate and critters like the earthworm to move through the soil. And so that biological activity, the more soil organic matter, the more biological activity. It's the food. The soil organic matter is the food that these organisms care about or need to live. So just to kind of bring it home, I've always thought soil science is kind of cool because it's not a pure science. You got to know a little bit about lots of different things. And you got to understand a little bit about biology and a little bit about physics and a little bit about chemistry, because all that stuff is interacting in soils. And soil organic matter plays a role in all of it. So you think about decomposition, nutrient cycling, that's biology, right? Structure, bulk density, porosity, water holding, infiltration, the way water can move from the surface of the soil into the soil. That's a physical property of the soil affected by organic matter. Chemistry, cation exchange capacity. It's a property of the soil that helps us hold nutrients in the soil. And it's also that substance that acts as a filter as we are thinking about our water moving through the farm field and through the groundwater into the Kentucky River, right? That's dependent on cation exchange capacity, and that'll absorb a lot of the things out of the water that you don't want to be in the water. And, we've got a couple other different things chemistry-wise that soil organic matter plays a role in. So this slide should look familiar. The first time I showed this picture, I said, what roles does soil play in the ecosystem? Well, what roles does organic matter play, right? It's tied into all these things is simply the point here. It's not to complicate things too much, right? One of my favorite books on soil health, and I thought about this after I put this slideshow together, and I put a couple resource slides in here at the end, but I left Dr. Magdoff out, and he and Harold Van Ness wrote an awesome book called Building Soils for Better Crops. And if you're new to this idea of soil health or building soil carbon, I highly recommend picking up this book. You can get it for free, I think, through SARE. They used to have an electronic download, and I think they still do. But this is kind of the original book that talks about soil science and soil building in everyday terms. You don't have to be a soil scientist to make sense of it. And so Dr. Magdoff came up with this notion of soil organic matter in that it's really more than just soil organic matter. It has several different components. He said it's the living, the dead, and the very dead. Right? And so the living, it makes sense. We've got living plant roots in our soil. We just heard Susanna and Jesse talking about how the roots exude carbon out, and that carbon becomes part of the soil, right? And the microorganisms feed on that carbon. And so the living roots and the microorganisms that are in the soil are part of the organic matter in this picture of soil health that we're building. I love this picture. This is one of my favorite. I use this in all my classes. It's one of my favorite pictures in all of soil science. And so this thing here is a root tip. And my students often say, well, Dr. Lucas, what's that other white thing with all the branches on it? That looks like a root to me. Well, that's not a root. That is a fungus, right? But then if we go back to this root tip and we look real close, we can see little wisps of fungus-looking stuff, right, on that root. What is fungus-looking stuff? Because it's a fungus. That's mycorrhiza. And those mycorrhiza are smaller than the diameter of your plant root. And those mycorrhiza can get into places in the soil that the root can't get. Even though that's the tip of the root, right? And we can see the tip of the root with the naked eye, but it's really small to our naked eye. That root can't get into those really fine pores in the soil. And so those mycorrhiza can, and the mycorrhiza live within the root and on the root, and they're able to take nutrients and water from the soil in places that that root can't get, and they bring it back to the root. And what do those mycorrhiza get? Well, they get a nice, secure, happy place to live, and they live off a little bit of the sugars that the plant makes from photosynthesis, right? So there's a nice interaction, right? They're living together. And as I mentioned, we got all kinds of other small insects, right? Arachnids, insects, nematodes, bacteria, fungi. Then you talk about the dead. This is the recently decaying stuff, the rye mulch, when Susanna breaks down her cover crops with the 2x4s or 4x4s, right? The rye mulch that's breaking down. This is the stuff that's easily decomposed, and this really stimulates microbial activity. It's food for animals and microorganisms. And so this stuff really interacts with those organisms and is part of that cycle that releases nutrients to your crops, but it also helps promote structure, microbial activity. When these residues break down, microbes release these gluey substances that help hold soil particles together and promote that soil structure. Then you've got the very dead. This is the stuff that the microorganisms have chewed it up and spat it back out, and this is what's left. Well, maybe spat it back out isn't the right analogy, but I'm not going to go with the analogy I'm thinking of. It's been chewed up and eaten and digested and put out, right? Humus. This is the dark stuff. When you're making compost, you're making humus, right? And this dark organic material is what gives our soils that deep, dark, rich brown color if we're managing it right, in the surface layer, in the topsoil. This is the part of the organic matter that has a lot of the chemistry that allows us to have nutrient holding. And it's also fluffy and light, and so it gives us water holding capacity and air movement and enhances that soil structure. That's me a few years ago in a lab. I wasn't quite as gray then. Those were the good old days. But, we can test this soil health. We can assess it. And it's not easy to assess. It's something that you can't just measure it with one aspect of the soil. It's how well does a soil perform all its functions. So you can't just say, oh, well, I'm getting high yields and say I've got a high quality soil. You've got to look at the big picture. And so if we're talking about assessing soil health, it's not a short-term assessment. It's something that you have to get some baselines on and monitor over time. And when I say monitor over time, I mean 2 or 3 growing seasons. It's not going to be measured with something that changes when you put a particular amendment out. It's not, that can change some things about your soil immediately, but soil health, while it may be tied to that amendment, it's not going to be directly measurable immediately from that one amendment. And so really what we're thinking about is improvements in your soil organic matter content, improvements in your soil structure, measures of soil biology, and some of these other physical properties that are based on how much soil organic matter you have, water and nutrient holding capacity. And so different soils are going to respond differently, and different management practices can change our soil health for the better or the worse. And so just for an example here, these are things that are going to change quickly. Your soil water content. It's, in Kentucky in June, it'll be dry one day and then you'll get some rain and then it'll dry out, right? That can change pretty quickly, your soil water content. Soil respiration is directly related to soil water content, and so that can fluctuate pretty quickly, just measuring the amount of CO2 coming out of a soil. A lot of people use that as a microbial test, but you got to be careful with it because it can change pretty quickly. pH, you go out, you put some lime on, your pH changes pretty quickly, right? So my point here, and fertilizers, right? We can certainly adjust the nitrogen, phosphorus, and potassium pretty rapidly in our soils. The point here is that those aren't really good measures of soil health, and neither are these permanent properties. Soil depth, if you're fortunate enough to have a nice deep soil with lots of topsoil and good drainage, that's a permanent property. It's there because of the material your soil formed in. If you're on a slope, well, that's something you've got to deal with, right? And you manage your farm to deal with that. And without bringing in bulldozers and excavators, it's kind of hard to change your relief, right? You can't. Well, I guess we can change the climate. I mean, humans have been working on that pretty good for the last 100, 200 years, but it's not something we can change rapidly, right? And soil texture, I don't know too many people that want to bring in dump truck loads full of sand or clay and dump them on their fields, so we really can't change that. We're in Kentucky, we're standing on top of limestone. It's kind of hard to change that, right? But all those properties do affect your soil health. It's just not stuff that we can change quickly. So what are we talking about measuring then? Things like aggregation, things like your microbial biomass. Basal respiration is kind of a measurement of microbial biomass. Labile carbon, remember Fred Magdoff, living dead, very dead? So labile carbon is trying to get at the living part. It's a measure of that carbon that the microorganisms can easily access and use as food. That very dead stuff, like I said, it's already been digested. And so the microorganisms, they'll break that down a little more, but they aren't going to do a lot with it. And then total carbon or total organic matter, that takes 5 years to a decade to be able to track real changes in, but you can measure that over an intermediate period of years. Let's say you're a producer and you want to learn more about this. Well, right now it's kind of tricky. There are not a lot of labs where you can just go ahead and send a soil sample and get your soil health tested. Waters does offer some commercial options. They do your basic soil test. When they say basic 4 soil test, that's like sending your sample over to UK Regulatory Services and you'll get your calcium, magnesium, phosphorus, potassium. They'll give you cation exchange capacity, pH, that kind of stuff, right? But then they do measure nitrate nitrogen and ammonium nitrogen, Solvita CO2 burst, which is a estimate of microbial activity, Solvita SLAN, which is a measure of microbially available nitrogen. Waters will give you active carbon, which is actually what I'm measuring here in this picture in the field. I was doing some active carbon work here at Kentucky State. It's a pretty quick and easy method to get you an estimate of what your soil organic matter looks like in the field, and you can watch how it changes relative to your baseline reading in response to management practices over a few growing seasons. The problem here is that a lot of these tests are kind of expensive, right? And unfortunately, there's not a lot of university lab options. My friend Steve Coleman up at Ohio State, he's actually now in Oregon, University of Oregon, he did have a soil health lab at Ohio State, and they eventually said, well, you can keep the soil health lab running, but we're not going to be doing producer samples because it's just not a money, it doesn't make sense money-wise. Cornell, I think, does have some soil health testing options, and I think maybe the other one is Oregon State that might have some options. But it's, your options are kind of limited. But some of this stuff is common sense. Farmers that have been on their own land and monitoring their land for years, they kind of know what, soil health looks like. You can get some of this from the way the soil feels. Does it crumble? Does it have good tilth, right? How does it smell? I mean, we've all maybe smelled like sort of soil that smells fresh and earthy. If you're getting like hydrogen sulfide smells, well, maybe you've got drainage problems, right? How does it look? This is one of my favorite pictures. This is my old advisor at University of Maryland, Ray Weil, and he's holding 2 clods. That's the scientific term there, right? Clods. 2 clods of soil in his hands. It's the same soil type. In other words, same soil series, and that's kind of the most narrow you can get when we're differentiating soils, as far as the type of soil you got, right? So this is the same soil series, but they were both managed in different ways. Someone tell me which one is the healthier soil? Our right, his left, right? The watch, the wristband hand, right? And you can see that. It's darker. It's got more roots moving through it. You can kind of tell from this picture, even on the grainy slide, that it's got more structure. The difference is that the one on the right was from a no-till. It's not organic, but it was from a no-till operation. Again, this was taken back in like 1997 or 98. Steve Groff's farm, Cedar Meadow Farm in Holtwood, Pennsylvania. He's a big no-till farmer, but he's also a pretty sustainable-minded guy. And he was using cover crops. I mean, if you look up Steve, he's sort of a cover crop guru. So he was doing lots of cover cropping, lots of biodiversity, interesting crop rotations, even though he was conventional, right? Conventional no-till. And this guy on the left is from his neighbor's farm. Same exact soil type, but the neighbor just liked to till the heck out of his soil and didn't really, he left it bare in the winter and didn't do much to manage the organic matter. And so that's the difference we could see in management right there. Let me go back. How do I go back? There. You messing with me? So when I was at Maryland, I had the privilege of working with Joel Groover and Ray Weil. And Joel, he was a couple years ahead of me in his master's program, and he actually went out and worked with farmers. He's at Western Illinois University now. He was out working with farmers, and he was doing this survey of farmer perception of soil quality. And what he found was that, when you put all the data that he collected together, it wasn't things like calcium to magnesium ratio or phosphorus or potassium that were correlating or relating to farmer estimates of soil health. It was all these things that we're getting at here and all these good presentations that we're getting here at Oak, right, about cover cropping or manuring or building your soil carbon. Those were the things that experienced farmers were talking about having relationships with soil health. Even back in the 90s, right, we knew this stuff. I'm going to skim over this. I've mentioned we can get into management. Tillage, erosion, monoculture crops. Hopefully we don't have much of that in here because we're at the Oak Conference, right? So we don't see much monoculture. Soil organic matter is about 58% carbon. If you ever want to test this, send your soil sample to University of Kentucky's research lab. Or regulatory services lab, and ask for both the organic matter test and the soil carbon test, and then when you get your results back, multiply the soil carbon, I think it's by, or divide the soil carbon by 0.58, and you'll get whatever answer is for your total organic matter. Roughly 58% carbon. Obviously, there's more than just carbon in organic matter. That's kind of my long-winded way of saying that. Again, as we manage it, we can change this stuff, right? And so soil organic matter is all about finding an equilibrium. And if we manage it really well, we're going to get an equilibrium that kind of builds and tops off. If you're not really doing a whole lot to manage, you might have some stable stable equilibrium that's below where we could get if we were actively managing to build soil organic matter. And if you're doing things like a lot of tillage without putting any organic material in there, right, you're going to deteriorate your organic matter. I'm going to kind of skim over this. We've all probably heard the relationship between keeping carbon in the soil and keeping carbon out of the atmosphere. Our plants suck up that carbon from the CO2 in the atmosphere. They put it in the soil from their plant residues in their roots, right? That's health, that's soil health, right? Building that soil carbon base in the soil. And, you know, side benefit, oh, well, we're helping to mitigate the problems that we have with CO2 in the atmosphere. And so I'm actually pretty excited to be part of 2 climate-smart proposals. USDA put out $1 billion worth of funds, and I'm with 2 different groups that got some of those funds to help farmers implement soil health building practices and track those practices. And so if you catch Brooke, you might want to ask her about that. I don't want to give too much more information because she's the lead on it, and so I'll let her tell you more. But I know that Oak is probably looking for farmer collaborators on that sometime in the pretty near future. And so how do we build the soil carbon? I mean, we've been talking about it for 3 days here at Oak now in different sessions. Cover crops, long-term rotations that last more than 1 or 2 years. We're talking diverse cover crops over 4 or 5 years. Stay away from the monoculture. Diverse crop residues, and I think Susanna had it in her presentation, right? Minimize disturbance, keep the soil covered, biodiversity, those are all things that we do to build soil health. Manure is a great option. Microbes like to feed on it. It's a soil organic matter builder. It helps recycle nutrients. We're connecting different farm aspects here, right? We're recycling nutrients from animal operations back to the soil that our plants can take advantage of. There's some evidence that manure can suppress diseases. The microbes that come in with the manure can sometimes outcompete some of the microbes that may cause diseases in your plants. You got to have a little planning with this. The rule of thumb is that the first year you put manure out, about 50% of it is going to become available. And then the second year after you put it out, 50% of the 50% that's left is going to become available, right? And so there's a little bit of planning that's involved. But, around here we've got lots of manure. Cows, horses, lots of animals out there releasing nutrient supplies and organic matter. Compost is another good option. It's not going to get you as much nutrient input because compost, as I said, is already decomposed, highly decomposed organic material, but it is really good for giving microorganisms places to live and enhancing your air movement and your water holding capacity in your soil, and it's also a great way of recycling the things that we may need to get rid of on the farm. This all takes a little planning, and one single aspect of it is not a silver bullet to help you build soil organic matter. One of the things that we're interested in here at Kentucky State is integrated crop livestock rotations. And so if you were on the tour yesterday, you heard me talk a little bit about this. A couple of us went and walked down to the actual organic section here at Kentucky State, and I was showing these plots off to a couple folks. We've got a 5-year rotation. I kind of stole ideas from John Bell. He's got similar ideas out on out in Georgetown. John, why can't I remember the name of your damn farm? Elmwood Stock Farm. I'm getting old and gray. I've been part of their CSA a few times and been out there lots of times and brain fart. Uh-oh. End of the conference. We've been thinking a lot, right? Anyway, what do you got? You got like an 8-year rotation with 3 years of vegetables and 5 years of cattle on the landscape. We kind of sort of shortened John's rotation and mimicked it a little bit with goats because we have a goat herd here at Kentucky State. And we do 2 years of organic corn and soybean, and then we follow that with 3 years of goats on pasture. And that's our integrated crop livestock system. And we're hoping to increase the organic matter, increase available nutrients, break pest and weed cycles, although so far I'm not really seeing it impact the Johnson grass in a good way. We still have plenty of Johnson grass when we grow corn and soybeans. The animals go in there and help clean up the fields a little bit. And if you're, obviously if you're a diversified operation and you're integrating animals and crops in your system, you got more than one line of cash, right? More than one line for profit. And so a lot of it, you got to think about the timing. You got to think about what farm you're on, right? Your own farm is going to be different maybe from your neighbor's farm or a farm a couple counties over. So a lot of this is farm specific. I prefer less aggressive implements. And as I was telling Susanna and Jesse earlier, one of the things that I really want to get into here at Kentucky State is looking at organic no-till. The producers are ahead of where the research data is at this point. And I'm real interested in starting to research, so that we can put numbers to the things that we know producers are seeing work on their farms. And then, if I can collect that data and it makes sense, then we can take it out in an extension capacity, and other people can learn from us. Start small. Too much, too fast can lead to problems. You don't want nutrient runoff and leaching. You don't want certainly manure to run off your landscape and cause bacterial pollution. And you can run into, in some cases, nutrient imbalances with compost and manure. All right, so let's look specifically at the integrated system we have here at Kentucky State. As I said, we've got 2 years of organic corn and soybean, and we follow that with 3 years of goats on pasture. And so there's a couple of the goats out in the field. We use that hay wagon. One time I called that a trailer, and somebody gave me a lot of heck for that. Said, farmers aren't going to listen to you if you call that a trailer. I took it to heart. That's a hay wagon. That's a hay wagon. All right, so they've got the hay wagon out there, and the goats like to climb, and they also like to have a little bit of shelter, right, when it's really sunny out. And so that hay wagon gives them something to climb on and gives them a little shelter. But we usually put them out for about 3 days, and this area here specifically is about 40 feet wide by 120 feet long. Research, right? It's research. It's not real farming, but we're trying to get data that might relate to real farming. And so, what's that? Our goats are super well trained. Dr. Andrews, that was here before, he had a saying, if you aren't behaving, you're off to Indiana, and Indiana was where his processor was, right? And so he, and the animals that are here are animals that have been bred here and trained here, and they know that when McKinley comes around with the bucket of corn and makes a couple of funny noises that I'm not going to make, they follow McKinley around, right? And so yes, they're trained, and that fence is electric. Right, it's solar-powered electric, and so they do know that if they bump it, they're going to get a surprise. And so generally, yes, they do stay in there. We've had a few that have gotten away. And so that's our corn. That's our organic corn in the background. And then this might be a pasture 1, pasture 2, or pasture 3. That number just depends on how many years we've had it in pasture. And there's a soybean plot somewhere back in there. We've got every aspect of this rotation represented in every year of our research because we want to be able to track the data annually. And if you're wondering what that PVC pipe is, and I'm not going to talk about it because it's not necessarily related to soil health, it is, but we are actually measuring nitrogen and phosphorus coming out underneath these plots. And so we've got water samplers under the plots, and that PVC pipe is our access to our water samplers, and so we can collect water and then get nutrient data. How much runoff or how much nitrogen or phosphorus are we losing through leaching? And of course, that can cause problems. Thank you, David. So there's just another picture of the goats hanging out grazing. On the left is a plot that's pasture they haven't gotten to yet. That's where they'll move next. And they're working on this particular plot. That's what it looks like when they're done. And incidentally, this plot here is our pasture plot that never gets animals, and it never gets, it's a control plot. It's always under pasture. And so the idea is that this is sort of our gold standard. If we don't disturb the soil at all, and we've got this diversified crop mix in here, and I think ours has about 6 or 7 different species in it. We've got a couple warm season grasses, a couple cool season grasses, some forbs like chicory and plantains. Festulium is one of the grasses that's in it. We've got fescue in there, right? Goats are not grazers. They're browsers. We're kind of forcing them to do something they don't want to do. But they will eat it when they're in there and there's nothing else to eat and they've got a fence keeping them in, right? And I mentioned earlier that in Susanna and Jesse's session, someone asked, where do we get cover crop seed? Well, we get some of our cover crop seed from Welters, and they do custom mixes. And so this custom mix that you see in this pasture has about 5 or 6 different, maybe 7 different species in it, and Welters was nice enough to help us out figuring that blend out. But the picture on the left, or the plot on the left, that's been grazed. The animals have moved on. This is our control, never grazed. We do occasionally mow the tops down to keep the Johnson grass seeds from getting out of hand. There is a little bit of Johnson grass in there, and so we, at least try to mow it to keep it from getting too out of hand. Let's take another look at a picture here. Yeah, you can see the goats are doing their job, right? These are something they've left behind. It's the good stuff that we want. A little bit of goat manure there. And our goal is to have them browse these plots with sort of a take 50, leave 50 attitude. Once they graze about 50% of it down, we're moving them to the next plot, ideally. That way, they're not grazing it down to the ground. They're grazing it enough to stimulate root production on the plants. And we want that root production because that's some of our organic matter, both from the carbon excreted from the roots and the roots themselves. And this plot here, I think, is a plot that hasn't quite, the goats haven't quite got to it yet, right? But this is what they leave behind, building organic matter. Let's look at some numbers. Brooke always tells me don't show too much data, but I like to sneak just a little bit in. And just to explain this whole system again, we have 2 controls. And so I explained the pasture control earlier. Never tilled, doesn't get animals on it. And the reason we don't put animals on it is because we do want to test that nutrient flow underneath the plots, and it's specifically the nutrient flow due to animals. And what we've seen generally, and it's not in this presentation, but what we've seen generally is that there's no difference between having goats on the landscape and not having goats on the landscape under these pasture plots. And so our goats aren't a source of nutrient pollution, which is good to know. But undisturbed, no goats, but undisturbed, right? And so that is perennial pasture. That's our positive control. This is our negative control, way over here. And in our negative control, we beat the heck out of the soil. Every year, it's organic corn, organic soybean, organic corn, organic soybean, organic corn, and it gets a cover crop in the winter, right? But it's not, other than the cover crop, we're not really doing much to help the organic matter content. And you can kind of see that. This is the first year after we take it out of pasture. This CS1 is when we have it in corn, and you could see we take a big hit in organic matter. This is the labile carbon. We measure that with permanganate oxidizable carbon, but this is labile carbon. And again, this is, Waters can give you this test. If you really want to know about your soil health, I'm glad to come out and do a soil health overview on your farm. I'm Extension, so I can bring my field test kit out. We can take some permanganate oxidizable carbon measures, but you can see this, these two are pretty similar, where we're beating the heck out of it or we've just tilled it for the first year. Soybeans, it's the second year, and in this particular year, for whatever reason, we got a little bump in organic matter. I'm not sure what was going on there, just maybe some random variability in the data. But then you can see when we switch to P1, our soil organic matter is going up. P2, it's going up more. P3, this is 3 years of pasture. It's almost back to where it was or where it would be in an undisturbed pasture. And so the idea is we are balancing out this detrimental, tillage-intensive organic grain production for 2 years with this undisturbed soil building with goats on the landscape over the next 3 years. And what I do like to always, what I was thinking about this morning as I was putting this together, and I've pointed it out a few times in other presentations, I mean, we are doing cover cropping on all of our cropped plots. And so, you know, one winter of cover crops is not enough to balance out the damage that you do if you're tilling, right? And so that's why we actually are really glad to see that our pasture implementation works the way it does in building that soil organic matter. This is soil aggregates. I'm not trying to trick you. I borrowed this from my graduate student and didn't have time to turn it into a graph that is in the same order as the previous graph. But my graduate student, Minaj Padel, is working on this. This is now the continuously cropped plot, and this is now the perennial pasture plot. And then he's got P1, P2, P3. And you can see that aggregates, the farther along you go under pasture, years-wise, the more aggregates you get. We're not quite back up to undisturbed, but we're building that aggregation back up. And again, that's going to help our airflow, water holding capacity. And it makes sense given we're also seeing organic matter building under those plots. So what do we need? What do we need to keep the soil healthy? We need more extension outreach. We need to understand the value of carbon. My friend up at Ohio State, Rafiq Islam, he and Brad Horman came up with this number that for every 1% of soil organic matter, it's worth $680 per acre in organic nutrients. Now, other people have grimaced when I show that number, and other people have said, I don't know if that's really accurate. We don't have a good idea. At least they're trying to put some numbers to it, right? And show that there is financial value in organic nutrients. And we need to figure out what these values are. It might not be the same in Ohio or as it is in Kentucky, or Kentucky as it is in Texas, right? So you've got organic is a regional, local thing, and we've got to figure out, soil health is a regional, local thing. And so we've got to figure out what that looks like in every place where we need to understand it. Just some basic resources. NRCS has a really good, if this has piqued your interest, NRCS has a really good primer. They talk about basic information. They talk about management tips, assessment information. They've got relevant, reading that can go with it. And so I recommend checking out what they offer on their website. They do also have, with NRCS, a soil quality test bucket. They're using the old term there, soil quality. And you can see, if you look real close, I'm not trying to pick on NRCS, but we do need some updates in the soil health and soil quality realm. This was put out in 2019, and they're recommending a book in the soil health bucket that is methods for assessing soil quality that I used as a graduate student in 1999, and it came out in 1996. And so the problem here is we need newer but also practical ways to assess. A lot of the ways that we have to assess soil health are either super practical, like crumbling the soil in your hand and looking at the soil tilth, or counting the number of earthworms, or they involve days worth of laboratory activity, right? And who has time for that? I'm a scientist, and I don't even have time for that sometimes. We need new methods, and that's on those of us that are involved in research to figure some of those things out. Extension is a resource. I'm not sure if Krista Jacobson over at UK has an extension appointment, but she is super smart about soil health, and she can point you to the right people within UK Extension. We are all one extension, though, which is why I made a point of putting that extension sign here. If you drive by your local extension office, you'll see the UK logo and the KSU logo. We're all one extension. We're all here to help. And so I'm Extension. If you need soil health consulting, I'm happy to come visit. Get me out of the office, please. I beg you. I beg you. Get me on the farm. I'll drive your tractor around for a while just for fun if you get me out there. All right. I think that's it. I have time for a little bit of questions.
Yes.
Yeah.
Questions for Shawn?
Yes, sir.
So when you were talking about spreading manure and things, so I've been researching this steep bedding, like in the winter, with wood chips. Would that hold the manure better? You said you have to worry about runoff. Would that hold it better when you spread it on your field? Or
So are you incorporating the wood chips, or are you keeping them on top?
it would be basically compost.
Yeah, okay. So, I mean, the wood chips may hold them better? So the question was, if you're adding wood chips to manure, will that help keep the manure in place in a scenario, say in the wintertime, where we might be more concerned with runoff, right? You know, and it just depends how you keep the wood chips in there. If they're incorporated, there's still probably plenty of manure that can run off. If it's a mulch on top, then it might keep the raindrops from hitting the manure. And you know, if you get enough water flow, you're going to have movement in your manure either way. I would caution, though, that with wood chips, you need to be careful with nutrient tie-up. If you go too heavy with your wood chips, the nitrogen in the manure is not going to balance that out, and you'll get immobilization, and then your crops aren't going to have the nitrogen they need. Yeah. Other questions? Yes, ma'am.
Do you have any experience with biochar application or humic acid application to improve organic matter?
I know enough about biochar to be a little bit dangerous. I haven't done a lot with biochar. We have a couple of researchers here at Kentucky State, Dr. Antonius and Dr. Geber Medden. I wish Dr. Geber Medden had been able to come this weekend. He's done a lot with biochar. It does give you a quick chunk of carbon in your soil, and it does have some chemistry that helps hold nutrients. It's not like microbial food carbon, but it does give microbes a place to live. And so if you have a really degraded soil, right, that you need a quick input of carbon to help hold nutrients and give it some tilth, then biochar is not a bad option, but you need to be careful and you need to research it. A lot of people sell biochar, and they sell it for a lot of different things. And you just got to do your homework on who you're buying your biochar from and really what it's made of.
Shawn, I get that question a lot, and majority of the soil tests that I do have a 7.5 or greater pH, and biochar is somewhat basic to begin with, so you are adding more basic to your soil.
I mean, my rule of thumb is if you can't, if you can't fix it, and you're right, David, I've seen anecdotal reports of that too. I haven't read deeply on it, but I've heard the same thing from other people, and it's something that has to do with the chemistry of the pyrolysis process, and so you do have to be a little conscious of that. But my rule of thumb is if you think you can build your carbon with using manure and cover crops and maybe compost inputs and smart crop rotations, or maybe even integrating pasture in your crop production, I don't like the biochar thing. Now, that's my opinion. Other people will give you different opinions on it. But if you want to get into a big conversation about the overall sustainability, where is that carbon coming from that is being made into biochar? And so are we, taking carbon from somewhere else, hopefully not cutting down forests to make biochar, right? Hopefully we're doing things like recycling pallets, to make biochar. But yeah, there's deeper conversations that could be had about that.
Anything else? Thank you, Shawn.
My pleasure. Thank you all.